In this video, we will continue to explore the properties of angle pairs and handle the algebra that occurs along the way. Now, in the previous video, we just already solved all of these problems. So we did 1 through 3, a whole page worth of these. So if you missed that, you might want to do a quick search and watch that first. All right, but here we go with number 4. So it looks like several of these problems are going to revolve around having a pair of parallel lines cut by a transversal. So let's do a quick review of some special names that we learned. When you have parallel lines cut by a transversal, then you can have corresponding angles, and those are angles that are in the same position if you look at sort of one group at a time. So for example, if you look at this group of angles around this intersection, see how this X is in the lower right hand corner? And then if I look at this group, this is also in the lower right hand corner. That makes these corresponding angles. All right, it would be the same deal if I had gone a different way. Let's say if my X were up here and my Y were here. Both of these are in the upper right hand corner. Upper right hand corner, they are corresponding. These angles, and those are going to be equal. See how they're both acute, all right, as opposed to obtuse? Like this is less than 90, this is greater than 90. When the lines are parallel, cut by a transversal, all of the acute angles are equal, and all of the obtuse angles equal each other. Anyway, alternate interior angles. When you hear me use this word interior, I'm talking about between the lines. So this zigzag is in the interior of the parallel lines. Anything outside of that, right? If I put some lines outside of here, like these green lines I just drew, these are in the exterior. So the white is the interior, and the green lines, that's in the exterior. So with that in mind, you can see that X and Y are interior angles because they're between the lines. Alternate means they're on opposite sides of the line. Okay? As opposed to consecutive interior angles, which are on the same side of the line. Still interior, but on the same side. Okay? By the way, alternate interior angles, those are congruent. See how they're both acute? You knew they would be congruent. Whereas these angles are going to be supplementary. Okay? When they're on the same side and they're sort of living in this cave together like this, those are supplementary. All right? Notice how one's acute and one's obtuse. And then this angle pair. You see these are exterior, right? Because of their outside. They're not between, they're outside the lines. But they're alternate exterior because they're on opposite sides of the line. Okay, so those are all the words that involve parallel lines cut by a transversal. These ones down here, linear pair, vertical angles, I really did not need to have parallel lines happening here. All right? They're not going to let me delete one of them, I don't think. Oh, they did. Okay. So for a linear pair, you don't need parallel lines. All you need is intersecting lines. So a linear pair, that's just two angles that together make a straight line. So you see the straight line right here, and it's split up into two angles. That's a linear pair. Those are going to be supplementary. Obviously, they have to add up to 180 because 180 degrees is a straight line. And then vertical angles. Again, vertical angles really don't have anything to do with parallel lines. If you have two intersecting lines, then vertical angles are going to be the angles that are like right across from each other. And vertical angles are always going to be congruent. So X and Y would be the same value. See these empty spaces here? These are also vertical angles. So I could have done it this way. XY. These are also vertical angles as well. Anyway, that's a lot of terminology. So let's see what we have. Okay, name the angle pair or state none if the pair doesn't have a special name. Then, okay, well, you know, maybe this is something different. Okay, so angle 1 and angle 5. So here's angle 1 right here, and here's angle 5 over here. Okay, actually, maybe I won't highlight it that way. Maybe I'll just go like this. Angle 1 and angle 5. So, see how these are outside of the lines? So these are exterior angles. And more than that, they're alternate exterior angles because they're on opposite sides of the line. Okay, so these are alternate exterior. All right, how about angles 2 and 7? So here's angle 2, and then here's angle 7. All right, that is your linear pair. See how together they make the straight line? That is a linear pair. Okay, that's like this. Okay, angle 1 and angle 4. I don't think we talked about this before, actually. But based on what we did talk about, I can easily come up with a name for this. All right, we talked about alternate exterior angles. Okay, but we didn't say what about if they're on the same side. Okay, so if these are consecutive interior angles, I don't suppose we can call these consecutive exterior angles. I think we have to call them same side exterior angles. All right, but they're definitely exterior angles, but they're on except for they're on the same side of the line. So I think we have to call them same side exterior. Okay, how about angle 2 and 3? Okay, so angle 2 and 3, these are interior angles, they're between the lines, and they're not alternate interior, they are on the same side. So when I was young, we called these same side interior angles, but apparently we're calling them consecutive interior angles these days. So I'm going to try to get with the times and call them consecutive interior angles. Okay, consecutive means like right in a row, right next to each other, sort of like adjacent. But adjacent, all right, now I feel bad for saying the word adjacent. Adjacent angles are actually sharing a common side. So angle 1 and angle 2 are adjacent. Angle 2 and angle 3 are not adjacent, but they are consecutive because they are nearby. All right, anyway, angle 3 and angle 5. So here's angle 3 and here's angle 5. Well, these are vertical angles. Remember when we spoke of that? All right, angles that are right across from each other when you have a pair of intersecting lines, vertical angles. Okay, what about angle 2 and angle 6? All right, here's angle 2 and here's angle 6. Well, these angles are interior angles. See how this is the interior of the parallel lines between the lines. But 2 and 6 are on opposite sides of the line. So not only are they interior, but they are alternate interior. All right, because they are on opposite sides of that line. All right, now part B. I'm going to give you one angle measure and you're going to give me the rest. But here's the bottom line, you guys. Maybe I'll just briefly write this off to the side. I mentioned this in the previous video. Obtuse and acute. All right? This is a right angle, 90 degrees. Okay? This is an obtuse angle. And that's bigger than 90 degrees. And this is an acute angle. That's less than 90 degrees. Why am I mentioning that? Because when you have parallel lines cut by a transversal, all the obtuse angles are going to be equal. And all of the acute angles are going to be equal. And obviously all right angles are equal to each other. Okay, so really I'm looking for two things. What are the acute angles? And what are the obtuse angles? Ha! Obtute. Oh man, I said acute and then I said obtute. What are the obtuse angles? Okay? And by the way, the acute angles and the obtuse angles are going to be supplementary. Like if I was told that the acute angle was 40 degrees, then the obtuse angle would be 140 degrees because they have to add up to 180. All right? So together, these should be supplementary. Okay? So that's what I'm looking for. So angle 1 is 140 degrees. Is that acute or obtuse? Obviously that's obtuse because it's bigger than 90 degrees. So I've got an obtuse angle of 140 degrees. All right, that means in this picture, all of the obtuse angles are going to be 140 degrees. And here, I'm going to use a different color this time so I can color coordinate them. All right, my acute angle, you know what, I didn't mean to do it this way, but I actually already did this problem. All right, if the obtuse angle is 140, then the acute angle must be 40. All right, because they have to add up to 180. And if I did 180 minus 140, that's going to be 40. Okay, so all of my acute angles are going to be 40. All of my obtuse angles are going to be 140. Okay, so here's what I'm going to do. In my picture, I'm going to go through and I'm going to color all of my acute angles green. Okay, so all of my acute angles. So acute, 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 acute. All right, every angle I just marked in green is going to be 40 degrees. Now I'm going to go through and mark all of my obtuse angles red. All right, so obtuse, 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 obtuse. All right, all of my obtuse angles are going to be 140. Okay, so let's see. So angle 2, that's an acute angle. So that's going to be 40. Okay, angle 3, that's another, that's an obtuse angle, so that's 140. Angle 4 is an acute angle, that's 40. Angle 5 is an obtuse angle, that's 140. Angle 6 is an acute angle. That's 40. Angle 7 is an obtuse angle. That's 140. And angle 8 is an acute angle. That's 40. All right, this pattern only holds if the lines are parallel cut by a transversal. If these lines weren't parallel, I couldn't just do it this way. Okay, number 5. Use this diagram for all questions below. Okay. So, we've got angle 2 and angle 4. So here's angle 2 and here's angle 4. See how they are both acute? And again, we have parallel lines cut by a transversal. So all of the acute angles will be equal to each other. They'll all be congruent. All right, these are corresponding angles, all right, and they're going to be equal. So that's why I'm going to set these equal to each other. So 3x minus 15 should equal 2x plus 7, all right, because these angles should be congruent. So if I want to solve this, I see the variables on both sides. I need to subtract 2x from both sides. These cancel out. Now I have x minus 15 is equal to 7. Then I would add 15 to both sides. So that's going to be 22. So x is 22. Now if I want to find the measure of angle 2, okay, the measure of angle 2 is the expression 2x plus 7. But now I know that x is 22. So this is 2 times 22 plus 7. That's 51. Now these two angles should be equal, so I don't need to calculate it again. I can just put 51. Okay, now for part B, I better erase because we're probably talking about different angles now. Angle 1 and angle 2. Here's angle 1 and here's angle 2. See how these are both acute angles again? They're going to be congruent. All right? These are alternate exterior angles. But as a shortcut, if they're both acute, they're going to be congruent. That only applies when I'm talking about parallel lines and a transversal. So anyway, these are going to be congruent. So that means 3x minus 17 should equal x plus 1. When you have variable on both sides, you need to get them together by subtracting one of them. So that's going to be 2x minus 17 is equal to 1. All right, these cancel out. Then I'm going to add 17 to both sides. So that's going to give me 2x is equal to 18. And then to get x by itself, I need to divide both sides by 2. Okay, so I'm going to get x is equal to 9. So now, I need to find the measure of angle 1 and 2. I'm going to go ahead and find the measure of angle 2 first, just because it's simpler. The measure of angle 2 is the expression x plus 1. But I now know that x is 9. So that makes this 9 plus 1. So that makes this 10. So the measure of angle 2 is 10. And remember, right from the beginning, we said, oh, look, they're both acute. These are congruent. So this is going to be 10 as well. Okay, now part C. Wow, we have 3 angles now. Okay, hold on. Let me erase some stuff. Okay, so we have angle 3, 4, and 1. Okay, so I have angle 3. All right, and then I have angle 4 and angle 1. All right, I changed colors because I wanted to show that these purple ones are congruent. See how they're both acute and they're vertical angles, which are always equal? These are congruent. Now, the red angle is not going to be congruent to the other ones. It's going to be supplementary. All right, the 4 and the 3 have to add up to 180. These are consecutive interior angles. They're supplementary. So look, focus on the 1 and 4. See how they're equal? Let's see if we can do anything with that. Well, you know what? Actually, I can't, because angle 1 and 4 involve two different variables. So I can't do anything with that. So I really have to start with the ones, I have to start with the ones that have the same variable, 3 and 4. So 3 and 4 are supplementary. They have to add up to 180. So that's why I'm going to do this. Okay, 3 and 4. So, okay, so the measure of angle 3 plus the measure of angle 4. Oh man, that's supposed to be a 4. Equals 180. So that's why I'm going to have 20x plus 11 plus 8x plus 1 is equal to 180. If you combine like terms, all right, the 20x goes with the 8x, and the 11 goes with the 1. So I'm just combining like terms. So 20x and 8x, that's 28x. 11 and 1 is 12. All right, then you would subtract 12 from both sides. So that's going to give us 28x is equal to 168. And then you have to divide both sides by 28. Okay, so divided by 28. So that is 6. So x is equal to 6. Okay, so now I have to find angle 1. But look, notice that angle 1 is the same as angle 4. They're equal. So let's start with angle 4, and then it should just be the same thing. So look, the measure of angle 4, that's the expression 8x plus 1. 8x plus 1. But now we know that x is 6. So that's going to give us 8 times 6 plus 1. 6 times 8 is 48 plus 1, so that's 49. Okay, so that's the measure of angle 4, is 49. Okay, that means that the measure of angle 1 is also 49. Okay, because these are equal, all right? Angle 4 and angle 1, right? They're vertical angles. So we just found that angle 4 was 49. That means angle 1 is 49. So why do I care? I still need to find y. So now I know that 5y plus 4 must equal 49. Okay? Because the measure of angle 1 equals 49. All right? Maybe it'll be more clear if I write it like this. All right, the measure of angle 1 is equal to 49. And we know that the measure of angle 1 is 5y plus 4. So all I have to do is solve this little equation. So that's going to be 5y is equal to 45. And then we need to divide both sides by 5. So that's going to give us y equals 9. Okay, in each diagram, is the information enough to guarantee the lines are parallel? Okay, and then we have to explain and stuff. Okay, look, vertical angles are always equal, regardless of whether the lines are parallel or not. So this is not enough to guarantee the lines are parallel. Okay, looking at our notes here, vertical angles are always equal. Remember how I took away the parallel lines? Because it has nothing to do with parallel lines. Same with a linear pair. Okay? If you have consecutive interior angles that are supplementary, that means you have parallel lines. If you have alternate exterior angles that are equal, parallel lines. If you have alternate interior angles that are equal, you got parallel lines. If you have corresponding angles that are equal, you got parallel lines. Vertical angles, linear pair, do not make parallel lines. It has nothing to do with it. Okay, so I'm going to say no. Vertical angles are always equal. Are always congruent. Whether or not the lines are parallel. Okay, what about this? First of all, look, these are consecutive interior angles. If these are supplementary, then that means I have parallel lines. So let's add them up and see if it makes 180. If I have 122 plus 57, that's 179. That's not 180. All right, so that means lines P and Q are not parallel. Since consecutive interior angles are not supplementary. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.